2.8 distance and midpoint circles preparation. Example, find the distance between the points -3, 5, and 6, 4. So the distance formula. So we write down the distance formula first. Eventually you'll be able to memorize the distance formula. You won't actually have to write it out every time. But one of the better ways to memorize things like this is just write the general formula before you use it a few times, and then at that point you'll probably have memorized the general formula and you won't have to write it out every time before you use it. Okay, so let's say we say x2 minus x1 squared plus, and then let's say we have y2 minus y1 squared, like that. Okay, so we want to label this as P1 is equal to x1, y1, and this is P2, which is equal to x2, y2. So now let's plug everything in. So the distance formula is equal to the square root of x2, which is a 6, minus x1, which is a -3. Again, be careful with your sign. You have a -3, or you're subtracting a -3. You're not subtracting 3. Okay, so be careful with that. Got to have that extra negative in there. Next, we're saying y2. It looks like y2 is a 4, and y1 is a 5. And then we square that. Okay, so distance is equal to 6 minus -3 is the same as 9, right? 6 plus 3 is equal to 9, 9 squared, plus. And then 4 minus 5 is a -1, and we square that. Okay. Now 9 squared is equal to 81, and -1 times -1 is a +1, so it's just +1, which gives you the square root of 82. Okay, so you have your distance right there. Nice. All right. Equations of a circle, center, radius form. A circle with a center hk and a radius of greater than 0 has an equation of parenthesis x minus h squared plus parenthesis y minus k in parentheses squared equals r squared. Now notice that the signs on both of these are opposites, and that's going to be come in handy whenever we're pointing out the center of the circle. Notice that the center of the circle is both the h and the k are positive, but in the formula they're both negative. So you're going to have to flip the sign when you're kind of translating this formula to the center, right? So when you're going from here to here, we're going to have to be aware that it looks like these signs flip, right? So we want to be aware of that. Okay, so find an equation of a circle with a radius of 3 and a center of 0, 0 and graph it. Now I'm going to do the long way, but I mean, first of all, I guess I could write the center, right? So you're just going to plug this in as the h, and you're going to plug the second one as the k. Okay, so we're just taking the original equation, but wherever we see an h, we plug in a 0. Wherever we see k, we also plug in a 0. And most of you can probably at this point see where this is going, because we're just subtracting 0. So it should just give us back the original one. Now they say the radius is 3, right? So where it had the radius in the original equation, we are going to be plugging in 3, and then we're going to have to square it. Okay, let's simplify this. So x minus 0 is just x, and x squared is just x squared. Y minus 0 is simply y, and y squared is just y squared, so we have that. And then 3 squared is going to give you a 9. So we end up with x squared plus y squared equals 9, and that's the that is the equation. I should have put a graph of an equation in here, but I didn't do that. Or yeah, I should have put a Cartesian coordinate system in here. So I'll just have to do my little. Hopefully my doodle one will be good enough, right? So this is, it centers at 0, 0. So I'll use a different color. So the center is going to be right here. Now, because it has a radius of 3, I'm going to go out 3 in every direction like this. Right? I'm going to plot a point. You know, up, down, left, right. Right? So, and then I'm going to try to draw a rough circle through all of these. Now, obviously, my circle is terrible. If we had some technology, this would look a lot better. But basically, it's going to look like this. So the center is at the origin because the center is at 0, 0. And because the radius is 3, you have to go in 3 in each direction. And then you're going to draw a rough circle like that. All right, so let's try it again. Find an equation of a circle with a radius of 5 and a center at 4, -3, and graph it. Okay, so we go back to the equation of a circle, which is going to be x minus the x value here, which is a 4, squared plus, and then we're going to have y minus, and over here we have a -3, so it's minus -3. Again, be very careful with the signs. It does make a difference. And then we have radius, which is 5. That's where we plug it in here. And now we are going to square it. Okay. So at this point, now we're going to simplify this. So x minus 4 squared is going to give you... Well, actually, this is an equation. This is good enough. I'll simplify it a little bit, but I won't expand it because this is perfectly okay. So you say negative minus 3, or subtract minus 3. That's the same as adding 3. So I will simplify that. And that gives me 5 squared, which is 25. So we'll just leave it at this in kind of a factored form. You could distribute this, and later on to do other things, you might have to do that. But right now, this is probably good enough. So let's graph this. Now in this case, notice that the center is at 4, negative 3. So 4 is over here. 1, 2, 3, 4. Negative 3 is 1, 2, 3 down. And the center's right here. Now from there, because the radius is 5, we need to go 5 in each direction. So from here it's 1, 2, 3, 4, 5. And then it goes down 1, 2, 3, 4, 5. Okay. So from here we're going to go 1, 2, 3, 4, and even 5 there. Okay, so there's going to be a point basically over here. 1, 2, 3, 4, 5. So there's going to be a point over here somewhere. There's going to be a point over here somewhere. There's going to be a point over here somewhere, basically. Now that's very rough, I get it, but that's basically the gist of it. So you're going to go 5 in each direction, and again, if you're using technology like my math lab, this is going to be way easier. Basically, you're just going to stick your little circle pointer in the middle, the center of your circle, and then you're going to pull it out the radius. So you'd have, in this case, you just pull it out 5. So you click, hold, pull out 5, release, boom, you got your nice perfect circle. Obviously, this is very rough and freehand, so it's not great. But it should look something like that, and that should give you the gist of it, right? So again, that's the center, and that's the radius. Okay? Let's try another one. So we want to find an equation of a circle with a radius of square root of 7 and a center of negative 1, 2. Now, I didn't write the base one for the previous one, and I probably should have done that. But the original equation is something like x minus h squared plus y, and I have it written up here. I had it right up here, so I didn't bother write it again. But it's x minus h within parentheses squared plus y minus k within parentheses squares equal r squared, right? So I'm just plugging the information they gave me into that equation. Okay, so minus k squared is equal to r squared. All right, let's plug it in. So x, that doesn't go anywhere, but minus h. Well, what's h? H is that negative 1 right over there, right? So we put the negative 1 there. Again, be careful with sign. It's minus negative 1. It's not minus 1. Those are two very different things. Plus, now we say y minus k, k being a 2. So then we square, and then r squared is going to be, we're going to plug in our square root of 7 here, but then we're going to square it. Okay, minus a negative 1 is the same as x plus 1, right? Subtract a negative is the same as adding, so we say plus 1. The other one is y minus 2. I'll just leave that. If you square a square root, there's kind of an understood index of 2 there, and these basically cancel each other out, leaving you the radicand, the stuff underneath the radical symbol, of the 7. So your answer is just going to be a 7, right? So how do you undo the square root of 7? You square it. Yeah, and that leaves you just the radicand, the 7, the meat under the radical sign, right? Now, I did mention before that you could expand these without having everything in a nice factored form. And this is kind of an example of one that where it's not in a nice factored form, right? And they want you to graph it. So first we want to find the center and radius of the circle, this circle right here, and then we want to graph it. You're going to, I'm going to rewrite it over here as basically x squared plus 2x plus I don't know. And we're going to figure that one out. Okay, I'll put that in parentheses to kind of keep that isolated. And then we're going to do the same thing with the y's. Y squared plus 6y plus I don't know. We're trying to get it so we can go to this form right here. So we're trying to complete the square so it can go into these little parentheses squared like we had previous to that, right? Now, what I'm going to do is I'm going to throw that 15 from this side to the other side to get rid of it. Okay. Now at this point, we need to figure out what the number that we need to put at the end of these to make them perfect squares. Now, we did this before, but quick review. You're going to take the 2, the middle term. You're going to divide it by 2, and then you're going to square it. So the first one is 2 divided by 2, which is 1. 1 squared, which is 1. And then we just add a 1 there. Okay? The other one on the other equation is going to be, we get the 6 6 divided by 2, which gives me a 3, 3 squared, whoops, 3 squared, which gives me a 9. And then we're just going to stick it in there. Okay, so let's rewrite it. So we end up with x squared plus 2x plus, oops, sorry, 1, got it mixed up, plus, and then we have y squared plus 6y plus 9, right? And that's still equal. Now, at the same time that we added a 1 and a 9, on the left side of this equation, for us to balance it out, if we're going to add a 1 and a 9 to one side of the equation, we have to add the 1 and the 9 to the other side of the equation to balance it out, right? So now we balance the equation. We added 1 and 9, which is 10 to one side of the equation. We added 1 and 9 to the right side of the equation, which is also 10. So that we have a nice balanced equation. Now these are both in a form that we can easily factor. So we're going to have square root of x squared is oops, sorry. So square root of x squared is x, and so then make it a little neater here. Square root of 1 is a 1, so I put the 1 there. Okay, so let me say plus, and over here we're going to say y plus 3 squared, and then that will give us 15 plus 1 plus 9 is a 25. Okay, cool. Now if we look back at the original equation, the way that we find the center is we take the opposite of the thing that modifies the x. So the center right here, is going to be, instead of a positive 1, which is what we have right here, it's going to give me a negative 1. And instead of a positive 3 right here, it's going to give me a negative 3, right? Okay, now right here, this part right here, this 25, that's actually r squared. So we know that r squared is equal to 25, but we don't want r squared. We want just r. So we take the square root of both sides, and that simply gives me a 5. Okay, so now we know the radius is 5. So we know the center is a negative 1 and a negative 3, and we know that the radius is a 5. Okay, so let's graph it. This is going to be super rough. Probably, you're going to have this test... you're going to be giving some graph paper, it's going to be online, so you won't have to draw such an ugly one like this. Okay, so we're going to say negative 1, which means you go 1 to the left, and then it's a negative 3, which means you go 3 down, 1, 2, 3, and then the center is right about there. And the radius is a 5, right? So we go 1, it's already 1, 2, 3, 4, 5. Sorry, I know it's ugly. 1, 2, 3, 4, 5. And over here we do 1, 2, 3, 4, 5. Okay, cool. So this right here is going to give you a big circle of wee. That looks awful. I'm so sorry. Anyways, I know that looks terrible, but hopefully you get the gist of it. You're gonna move 5 units equidistant in each direction, draw plot a point, and then try to make a nice little circle. That's pretty bad. I realize that. Hopefully that's okay though. You get the gist of it.